Welcome to I'm Not Afraid of Math Anymore, Math Foldables. In this lesson, we will continue to look at algebra functions and graphs, and we will learn about rate of change, which is also called slope. In this foldable, we will learn how to find rate of change in a linear function graph, a linear function table of values, and a quadratic function graph. We can find rate of change in a linear function graph. The rate of change tells how sloped or slanted a graph line is. To find the rate of change between the 2 points in the graph below, count up and over and write as a fraction. Think of it as the driving directions between the points. We're going to start at this lower point and we're going to count up 3 spaces and put that number in the top of the fraction, and then we're going to count over 1 space and put that number in the fraction. So our rate of change, or our slope, is 3/1 for this graph. Looking at the right, we continue on. The equation of a linear function can be written in this form: y is equal to mx plus b. M is the rate of change, which is also called slope, and b is the y-intercept, which is where the graphed line intercepts the y-axis. Determine rate of change and write the equation for the graphed linear function above. We start out with y equals, and then we determine the rate of change. So rate of change will be starting at the lower point and going up 1 and over 3. So we've written the slope right here as 1/3, 1/3. Then we put the x in, and then we look for the y-intercept. This is the point where the graphed line is intercepting the y-axis. And so we write +4. That is a positive 4, so we write +4. And that is the equation of the linear function that goes with this graph. We can also find the rate of change in a linear function table of values. We see here a table of values for Olivia's growth. In the left column, we have our X numbers, which is for how many months old Olivia is. And in our right column, we have numbers for her height in inches at each of those months. Find the rate of change in a table of values. Find the difference between the y numbers for the top number of the fraction, and then find the difference between the x numbers for the bottom number of the fraction. So in this example, for our rate of change, we are subtracting 34 minus 30, and then we are subtracting 36 minus 24. We got all of that from our table of values. 34 minus 30 is 4. 36 minus 24 is 12. So this is our rate of change, or our slope. But we could reduce that fraction to 1/3, so our final slope or rate of change number is 1/3. Notice that we could have also chosen to say 30 minus 26 and 24 minus 12. That would have worked just as well. 30 minus 26 is still 4, and 24 minus 12 is still 12, and that would still give us a slope of 4/12, which would reduce down to 1/3. Remember that the graph of a quadratic function is a curved line, not a straight line. So we can't exactly find a rate of change, but we can find the average rate of change as the line is curving. It's constantly changing a little bit. Find the average rate of change of the function from x equals 2 to x equals 6. This is really asking us to imagine a straight line connecting the 2 points on the graph that begin with 2 and 6. That's this point right here and this point. We have gone over on the x highway to 2 and gone up to the curved line, and we've also gone over on the x highway to 6 and then gone up to the other point on the curved line. Then we find the rate of change or slope of that line, the straight line that would be connected between those 2 points. We start by subtracting the y numbers. We're going to write down the addresses of the points. So our top point is 645 and our lower point is 25. We will be subtracting the y numbers, so 45 minus 5 is 40. That's the number that will go in the top of our rate of change. Then we will subtract the x numbers. Again, the addresses of the points are written out as 645 and 25. This time we will be subtracting the x numbers. So 6 minus 2 is 4, and that goes in the bottom of our rate of change. Now we can reduce that. 40 divided by 4 is 10. So that is our average rate of change for this curved line.